A positive 2 coulomb charge carrier has a velocity of 2I minus 3J minus 4K meters per second. It travels through a region of uniform magnetic field that has a magnitude of 4 Tesla pointing along the negative y-axis. What vector force is experienced by the charge carrier? So in this problem, when they say vector force, they mean magnetic force. And whenever you're given a problem that asks for magnetic force, you want to remember that the equation to solve for magnetic force, aka the force of the magnetic field, is equal to the charge times the cross product of the velocity vector and the magnetic field vector. So let me repeat that. F sub B stands for magnetic force. Little q stands for the charge. V represents the velocity vector. And B represents the magnetic field vector. Okay, so we know from this problem that the charge is a positive 2 coulomb charge, so this is 2, okay? But we don't know the cross product between the velocity vector and the magnetic field vector yet, so we need to find this. And to find that, we need to list out both of our vectors. So V is going to be equal to 2I minus 3J minus 4K, okay? But what's B? It says here that the magnetic field has a magnitude of 4 Teslas pointing along the negative y-axis. And in IJK form, I stands for x-axis, J stands for y-axis, K stands for z-axis. So since it's pointing along the negative y-axis, the only value that is going to be present is the y-axis, which is our J. And it's going in the negative direction. So I will be 0, J will be a negative 4, and Z will be 0. So this would be your magnetic field vector, okay? Now, to find the IJK of these, IJK, also known as V cross B, the cross product of these, you want to write down the V vector, so 2I, negative 3J, and negative 4K, and the B vector, so 0I, negative 4J, and 0K, okay? And V cross B is going to be equal to find the I component of this vector. You're going to cover up the I, and then you're going to multiply the J and the K components together. So on this side, negative 3 times 0 is 0, minus negative 4 times negative 4 is positive 16, so 16I, minus, we do minus because whenever we do IJK, our answer will always be something I minus something J plus something K. And our J could be a positive number, but our foundation is always I minus J plus K, okay? Now, to find our J component, we cover our J, multiply 2 times 0 is 0, minus 0 times negative 4 is 0, J plus, cover our K, 2 times negative 4 is a negative 8, minus 0 times negative 3 is 0, K, which will give us negative 16I minus a minus 0, same thing as plus 0. So you could do plus 0, minus 0, doesn't matter. I'm just going to do plus 0 because I like being positive. I like being positive, so we're going to do plus 0. So, and then negative 8 minus 0 is a negative 8. So, there you go. This is our vector v cross vector b. So, we can now write here that it's going to be a negative 16i plus 0j minus 8k. All right? So, next step is to plug these values in to our original equation. So, I am going to erase this so we have more space. For our calculation. Okay. Given that we have this now, let's rewrite it. The magnetic force is going to be equal to times negative 16i plus 0j minus 8k. So you can plug it into a calculator. We don't need to use a calculator for this one, but for tradition, I'm just going to use a calculator. We can distribute the 2 to all 3 of these terms. 2 times negative 16 is negative 32. So we have a negative 32i. 2 times 0 is 0. J, 2 times 8 is 16, negative 16. 2 times negative 8 is negative 16. So we have negative 16k. And this would be our magnetic force vector. And units would be in newtons, so this would be your answer.